If you want to just pull up your slides, I'll introduce you while you do that.
Oh, okay. Yeah, I was gonna make it here. Just a sec. Let me pull them up here. I'll make a comment with the slides up though.
Yeah. So our next speaker is Shane Larson. He's a professor at Northwestern University and also the associate director of Sierra there. And he's an expert in gravitational wave astrophysics and data analysis, and also one of the chairs of the Astrophysics Working Group, which he'll tell us all about now. So take it away, Shane.
Okay, great. Thanks, Will. Thanks to the organizers for inviting me. It's certainly a great pleasure to be here, and it's certainly a great pleasure to see kind of burgeoning interest in LISA. So hopefully this will lead to some fruitful future collaborations. Let me just say at the outset here, so I'm here representing the Astrophysics Working Group, of which I am one of the co-chairs. And from the perspective of doing LISA science, I think the opportunities here are tremendous. And to some of the earlier conversations that I've been listening to over the last couple of sessions is, the opportunities here are enormous, and they're in fact limitless. There is plenty of work that the consortium directly needs done and that we need to accomplish in order to make LISA happen. But the opportunity for general astrophysics work related to LISA and in anticipation of LISA data is really quite extraordinary. And we'll touch on some of that here as I have just a few slides to tell you about the working group. And I can certainly tell you a lot more to someone's earlier question about how to get involved. The working groups, as Martin intoned, is certainly one way to do that. And there's certainly lots of opportunities, and certainly nothing is very rigid. So we can talk about that as we go along. I am at Northwestern University. I've worked in virtually every aspect of LISA except actually putting soldering irons and screwdrivers down. I do data analysis, I do instrument characterization, but mostly I work on astrophysics. My group has worked across all the source classes, and we do a lot of interdisciplinary work, which of course is what our center at Northwestern is focused on. And it's certainly very, very amenable to the sorts of work that we do on LISA. So let me just tell you a little bit about the working group and some of the things that we're up to kind of give you a lay of the landscape of what it would look like if you came and participated with us in LISA. So this is one of the charts that you can get from the LISA consortium about the description of the consortium. It will hurt your head if you try and make it add up to one. It does not. It simply shows all the different sizes of all the groups, and many people participate in different groups together. The largest piece of the pie there, that pink wedge, is the full consortium. We're 1,400 or 1,500 members. But of all the remaining working groups, the Astrophysics Working Group is the largest. And so there is substantive interest across the consortium in terms of the LISA science. We have about 480 members right now. We have 4 co-chairs. So this is where the consortium, as we grow and we expand, we're kind of settling in on a standardized structure for leadership. So each of the working groups has a set of chairs. So these are the 4 co-chairs here. Lucio Meyer up there in the upper left is at Zurich. Gijs Nederlemans is in the Netherlands, and Marta Voluntari is at the IAP in Paris. So the working group chairs will slowly evolve. We're about to have our first evolution and rotation off. We're trying to build pathways for early career scientists who are interested in participating in leadership and management in the consortium ways in. So we're expecting an early career scientist to join us in leadership here. And that will happen over the next, I would guess, half a year or so before we go. But we're only 4 of the 480 in the consortium. And so the working group, our entire goal is to do the sorts of stuff that we're talking about here at this meeting, which is to foster work and collaboration, specifically on problems that are either about LISA science or on problems that can benefit from LISA science. What sorts of questions, what sorts of astrophysical phenomena, what kinds of science questions can LISA data help us address? And so there's all kinds of ways that you can do that. But the whole aspect of having a large working group within the consortium working together is so that we can really strengthen that community of people who is thinking about LISA in this way. help provide opportunities for us to collaborate, to kind of push our science further along, but also to provide the expertise to the consortium that they need, both to help the LISA mission progress forward, and ultimately, once LISA flies, to help us work with the data once it comes down. The sorts of things that we do in the working group are very open-ended. We have folks who work on pure source characterization, working on how the astrophysical properties of a source translate into gravitational wave signals. We have people who are working on the origin and evolution of sources so that we can understand astrophysical rates or the number of the different kinds of opportunities for signals that we might detect. We work a lot on populations, which is also related to rates, but is also related to a variety of science questions like channels of formation for different kinds of sources, and also imprints of astrophysical processes. How do certain behaviors in certain systems imprint themselves on the gravitational wave data so that you can then use the gravitational wave data to measure those processes. So we have people working across all of these areas within the working group, and it provides for, as you might imagine, a very rich and dynamic environment. So really, we have within the group anyone who's interested in LISA sources, whether they work in computation. We have lots of theorists, as you might imagine. I myself am a theorist. We have people who work on current observations and people who are certainly observers on the electromagnetic side, and just really the whole gamut of different ways of approaching the science. I've listed there at the bottom, just to make the slides more interesting, the kind of 4 classic source classes. You've probably heard some of this already, and you'll certainly hear more of it. We, in the astrophysics working group, this is kind of the breakdown we often settle into. We ultra compact binaries or stellar mass binaries of all combinations, primarily in the Milky Way, but also expanding out into the nearby universe. Massive black hole binaries at the centers of galaxies, which LISA should in principle be able to observe all the way to the cosmological horizon. MREs and IMREs, which you've heard a little bit about, but also the emerging science surrounding multi-messenger astronomy. And I think one of the things I like to remind people is that right now we're very much thinking, we often think about multi-messenger astronomy in the context that our LIGO colleagues do, where it's a very transient, we have to be ready to suddenly throw every telescope on the sky to look at a particular source. But LISA multi-messenger astronomy isn't necessarily going to be that way. There are known multi-messenger sources even now that we see. There will be more multi-messenger LISA sources than any other gravitational wave source in any other wave band. So for those of you who are interested in multi-messenger astronomy, there will certainly be lots of opportunities there. So what do we do in the working group? Well, we got to get everyone together to kind of foster those collaborative opportunities that we're interested in. So there are regular consortium meetings, which you may have heard about. And then every few years, we have a big symposium. We try and always meet at those big meetings when we do. But over the last few years, we've been trying to have face-to-face meetings where people in the working group just get together. We had our first one in December of 2018 in Paris. We had our second one right as the global pandemic was breaking out in March 2020. So it was a hybrid meeting. Only about half of us who were originally intending to go actually went. That was in the Netherlands at Radboud. And then we're currently planning our next one for June 21, which will be completely virtual and will be hosted by our colleagues in Zurich. What we usually do at those meetings, we have a few science talks. We have a lot of orientation to the consortium and updates about what's going on, the sorts of stuff you and I are talking about right now. But we've been trying to foster the launches of big projects across the working group. And so the big one, which we're just wrapping up, I'll tell you about in a moment, is the Astrophysics white paper. And then at the meeting we're about to have, we're trying to launch some working group wide projects to try and stimulate some collaborative work within the working group. And those pictures down at the bottom are just boards from our meeting in Paris. You can see we did a lot of back and forth as we talked about this sort of stuff. So let me tell you about the white paper. You all will be able to see this very soon. So it will provide a little bit of the landscape for you if you're interested in all the different sorts of things that we think about in LISA astrophysics. The idea originally was within the consortium to produce some white papers that would capture the current state of LISA science. And that's not just us in astrophysics, but it's also our colleagues in waveforms and our colleagues in data analysis and our colleagues in cosmology as well. And so each of the working working groups has been writing a white paper. As you might imagine, they grow organically and become quite large. And ultimately, they're going to go out and be published in the open literature so people can find them. Within the working group, we use this as the kind of first big working group wide project to try and help synthesize people together, help them meet colleagues who do things that they also work on, foster some collaboration on common projects, and help stimulate ideas and opportunities to work together on future projects. So we broke the white paper up into these kind of classic source classes that I told you a couple of slides ago. Stellar mass multiples, meaning the compact binaries, massive black holes, and extreme mass ratio inspirals. We had started with 4 chapters where we were going to have one chapter on multi-messenger astronomy, but ultimately, those of you who do multi-messenger astronomy know it's quite different for each of these source classes. So we broke it apart and then put the multi-messenger discussions into each of the individual chapters. So I think I speak for all my co-chairs that we think this was a remarkable success. We had more than 100 active people contributing to the white paper. So that's 25 or 30% of our working group. We had substantive contributions from our early career people, which we really appreciate and we're encouraged by. In the end, the current version of the white paper is about 225 pages and it has about 1,500 references. And so more than anything else, I think that 1,500 references is an extraordinary resource because we have often talked about the scope of the LISA literature in astrophysics. It is enormous, but it's nice to see it all in one place. And the image here is Overleaf kind of really has difficulty compiling the document that long. So it just sits there and compiles for a couple of minutes when you log on. So what about future working group activity? So as we said, right, our goal is to foster collaboration and work in LISA-related astrophysics. So the white paper is the kind of the first successful thing that we've done on that, and we're certainly very proud and happy about that. We just, in the last couple of weeks, had a very first workshop, a small 2-hour workshop where we were talking to gravitational wave folks, LISA folks, and EM astronomers, and put us all together in the same room. There are about 50 of us. To talk about what kinds of EM observations can be done in the pre-LISA era that would inform and advance LISA science either before LISA flies or that would be good to have data and information on hand when the LISA data first arrives. So that was a really successful workshop. We are currently organizing people into little subgroups, and we're gonna come back to that at our meeting in June and have some reports and discussion about what people are thinking about so we can try and organize some common work. We are at the June meeting going to work on these collaborative working group wide projects that I told you about. So really what we want is big flagship projects, again, to build this kind of collaboration across the working group. We want to focus on projects that are kind of key to the LISA science. But really the point here is that there are lots of projects. The LISA sciencescape is so large and so expansive in terms of what's possible and what we know and what we don't know, that many projects that really address the key LISA science can't really be done by a single group. They require wide expertise from many areas and different kinds of inputs, whether it's from data analysts, from source simulators, from population synthesis people, from HPC people who have codes that can run for months at a time, whatever. Okay, and so there are many flagship projects that require those kind of big collaborative efforts. And so what we're trying to do is we're going to propose a straw list of projects that we've been thinking about. We've already had that discussion at some of our previous meetings, but we're going to put it out to the working group and see what folks are interested in and see if we can start one of these flagship projects. Our policy in the Astro working group is for it to be open to all working group members. And so certainly those within the consortium who are interested in joining us will have the opportunity to participate. So I'm going to end there. We have a few minutes. I'll certainly leave them for questions, but if you don't want to ask me questions now and you do have questions later, you can email me and all the co-chairs directly. We have a mailing that goes to the 4 of us there, astro-wg-chairs@lisamission.org. You should certainly feel free and welcome to send us email either about LISA science, about the sorts of things we're working on, or about ways that you can get involved if you're interested in participating with us. Okay, so I'm going to end there and say thank you, and I'm certainly happy to take questions from anyone who wants to chat.
Thank you so much, Shane. I'll applaud for everyone. Yeah, so we have plenty of time for questions. So if you have any of those, just put them in the Zoom chat. We can get those answered. So maybe while people are typing, I have a question, which is, so you mentioned some of these like flagship projects to try to get the whole working group together. Do you have a couple examples of those? Just to
so let me give one that actually overlaps with my own some of the research that's going on in my group. So one of the things that we deal a lot with is the foreground of galactic compact binaries. So the Milky Way will have some 10 to 70 million ultra compact binaries in it. That is so many that they will merge together and form a confusion foreground. And if you're a binary astrophysicist like I am, that's signal. And if you're a supermassive black hole person, that's noise. And so there's tremendous need to characterize what those foregrounds might look like and how they can be dealt with. Now, one of the issues right now, of course, is we haven't observed the foreground with LISA. So we don't actually know what it looks like, right? What we know is what the current bounds on the population might be from existent astrophysical observations. We know what the current bounds might be based on our population synthesis models, which is something that my group works on. But the range of possible outcomes is actually larger than is probably comfortable for many of us who are astrophysicists. And so one of the interesting flagship projects we could do, which requires a bunch of collaborative effort, is to take all of us who can make synthesized populations of the galaxy, talk to all of our observers who know what all of the bounds on the galactic properties are, and synthesize different representations, different realizations, different real fake representations of what the Milky Way might be, and then run them all through a common LISA analysis to say, what are the possible things that we might be able to walk into your office a year after LISA starts taking data and throw down on your desk, this is what LISA thinks the Milky Way looks like. We don't know what that range of possibilities is yet. And we can't answer that question unless all of us who do these different kind of aspects that kind of tell us what we think we understand about the galaxy might be. So that's an example of one of the binary ones. There are similar ones. If you look at the massive black hole binaries, there's been tremendous work put forward on trying to understand what the possible electromagnetic signatures might be. And there are substantive and very different answers if you use 1D models or 2D models, if you have different hydrodynamic approaches to the gas, whether or not your models have mini disks around the primary black holes. So again, there's an opportunity there to have a synthesis project where we try and meld together to try and answer very specific questions, especially now, well in advance of LISA, what we should be preparing for the possible electromagnetic counterparts to a supermassive black hole binary, right? And so the list goes on. You can, right, if you just survey the LISA literature, you can imagine all kinds of different projects that a group could ask, that we can ask easily in conversation like this, but that actually require more than one or two groups to answer. It's going to require many minds at the table to put all the pieces of the puzzle together to see what we can actually do.
Thank you, Shane. So I see other questions in the chat. So one is from Aaron. Is there work going on for unmodeled burst-like events in LISA? And is this the purview of the waveforms group or the astrophysics working group?
Yeah, that's a great question. So I will say that we have working groups that are named in the LISA consortium. So we definitely have a data analysis working group. We definitely have a waveforms working group. We definitely have an astrophysics working group. But there's considerable overlap, especially on questions like this, between the working groups. And so, you know, where you sit and which working group you'll be in is largely driven by your interest. But ultimately, I think if you're interested in a particular topic, like what do unmodeled bursts look like, and no one in the astrophysics working group is working on it, then you definitely go over and you go talk to the folks in the waveform working group. If you go back to that chart I showed at the beginning, right, the numbers don't add up to 1 because many of us belong to multiple working groups for exactly this reason. Specifically on that question of unmodeled bursts, this is a really important question. It's a perennial one in all the different gravitational wave bands. There is work being done by our data analysis colleagues on how do you deal with the fact that there are unmodeled bursts. A lot of the work that I know about on that is about generalizing techniques that have been used, for instance, previously in LIGO to the LISA data analysis infrastructure. But also there's a lot of work from our colleagues in instrumentation, because one of the problems with unmodeled bursts is that non-stationary noise often can look like it. And so if you're a good instrument noise simulator person, then you also work on that front as well.
So another question from Ilse Yoon, who asks, is there a LISA pipeline that simulates the predicted LISA signal for given populations of sources?
Yeah, so there is an effort within LISA called the LISA Data Challenges, the LDC, and I don't remember from the schedule if you're going to get a talk about this. But part of what the LDC has done is they're trying to build standardized tools that allow people to work on this. So they definitely have a pipeline that generates, for instance, it'll take a galaxy, a simulated galaxy, and generate what the LISA data stream looks like. And so what they've been doing is they've been outputting successive data challenges that have different sources and different, let's call it difficulty levels in terms of the data. So there's, I think the first one just had galactic binaries. There's now one that has 10 supermassive black holes and galactic binaries. There's one that'll have emeries in it, and so on. So those data streams are available, so you don't have to actually run the pipeline to make the LISA data yourself. But the pipelines, if you join the LDC effort, are certainly available to people who join the LDC. I think the LISA data challenges is actually open to anyone, even if you're not in the consortium. You just have to register, and they'll give you access to the LISA tools that they use. So. Oh, thanks for the link there, Joey. I see Joey put the link in the chat. So.
Any other questions?
Okay.
Can I say just a live question?
Sure. Hi, Daryl.
Hi, Shane. How are you? It's nice to see you.
I'm good.
I am wondering about group dynamics. So you're managing this very large group. And so let's imagine I'm a grad student and I think, wow, 2035, that's fantastic for me, but I don't know how I'm ever going to get, rub shoulders with or get to know all of these fancy people that lead this working group. How does the engagement of junior scientists work inside of the collaboration, inside of the working group? And do you have specific strategies you employ? How does one kind of conceive of that looking forward into this long?
That's a really good question. And it's, I mean, those of you who have been in this game a long time, whether in particle physics or gravitational wave physics, know it's a problem in these big collaborations. And it's really difficult from the perspective of a junior person. Daryl and I are farther along in our careers than when we were junior people, but it's you want to make sure that your work gets recognized. And in a big collaboration like this, there's always this fear that it'll get hidden. So one of the things that So let me say a couple of different things. So one of the things is I think there's a lot of us in the kind of middle management of LISA who try and be really mindful of this. We do our best to promote young people. We know they don't speak up when we ask for people who want to work on this, that, or the other, but we'll say, oh, I know this person might be good at this, and we'll reach out to them personally to try and do it. But I would say one of the most remarkable things that's happened in the LISA Consortium that I really appreciate, and I think we're all coming to appreciate the importance of, is that we have, I don't know where they are in the giant org chart, but we have a LISA Early Career Scientist Group, LEX. And so this is folks in their early career. It's grad students, postdocs, junior professors who have banded together, and they have regular meetings, they have regular telecons, they make reports to the consortium, to all the working groups, to really talk about how's it been going, are you able to participate, what challenges are you facing, what would you like to do and can't, and they broker a lot of that in places where faculty or senior people just aren't paying attention when they should be. And my impression talking to the students and the postdocs I know is that they have found that community very supportive and rewarding to be in. And I would say those of us in the LISA leadership have found it very helpful to have a voice in our meetings always that says, you know, Lex was talking about this and we should definitely remember to it, because it helps us not forget, because it's so easy to just kind of get rolling the way we do. So so Lex is definitely a really important and vibrant part of the consortium right now that addresses exactly these sorts of things. So
great, thank you. So there's a maybe related question in the Zoom chat, which is how feasible is it for early career people to get involved in LISA working groups without applying to the consortium as a part of a group of applicants?
Yeah, so to be in the working groups, you have to be in the consortium. So that's certainly the case. There are plenty of people who work on LISA related science, or LISA adjacent science, if you want to call it that. And plenty of us in the consortium collaborate with colleagues who are outside the consortium. So that's certainly, not being in the consortium shouldn't preclude you from working on something related to LISA. I will say that the way the consortium membership is currently structured, and maybe Martin will comment if he thinks I get this wrong, but we have kind of two levels. We have what are called associate members and full members. And those of us who are full members, we take a much more active role in addressing what the consortium needs done. We're either in leadership, or we work on task forces, or we produce data pipelines that they're going to use for validation, whatever. But the associate members are members who are basically advocating for LISA. They're doing LISA science. They get all of our information. They come to our meetings, but they don't have any assigned kind of responsibilities directly in the consortium. And so, for instance, in my group at Northwestern, almost all of my graduate students are associate members. So, and that allows them to participate in LISA, in the consortium, but it allows them to focus on their own personal science without having it be sidetracked by whatever the consortium needs this week because we have a report to give to ESA or whatever, right?
Great. So I think we're about out of time.
Sorry, William. I just wanted to add one thing to what Shane said, which I think is important based on that question, and something I said earlier, which is we typically take in groups into the consortium, but that's not strictly true. We actually accept many single person groups, if you like. So there's no real bar there. So if there's an early career person who wants to join the consortium just on their own, there's no problem with that.
Great, yeah, thanks for that clarification. Yeah, so I think we're about out of time for the session. So Shane, let me thank you again for a very nice talk. And if people have any further questions, put it up on Slack.